Hello everyone, today I'll be teaching you guys simple harmonic motion, second pendulum and mass spring system. So first of all, with second pendulum, it is the simple pendulum in which the time period is equal to 2 seconds. Now the time period of a pendulum is 2 pi root L by G, which is equal to 2. So these two cancels, giving us 1 here, and basically we have to find the length because we can assume gravity to be 9.8 meter per second at sea level. So if we do a rough calculation, this becomes L equals to 1 by pi uh, G root, right? G by pi square, because if you square both sides and then you put a pi here, you'll get this. So this will be equals to, well, nearly equals to 0.993 meter, which is equals to 1 meter. So what this entails is that if the length of a simple pendulum, the string of the simple pendulum is 1 meter, then the time period of oscillation will be approximately 2 seconds. So now let's start with the mass spring system. Now there are two types of mass spring system. One is horizontal and the other is vertical. Now the vertical mass spring system is also, the spring is called the helical spring. So first let's start off with the horizontal one. Now here this is quite simple. Let's say you have a fixed end and you have a spring with a mass m attached to it, and let's say that you give it some force so that it displaces from, well, a distance of x, and here you have to have applied some force F. Now let's say the displacement is y. So here during this system there is some elasticity caused in this spring, and, well, we can use Hooke's law, which states that the restoring force F is directly proportional to the extension produced, which is y, or here F is equals to minus ky. Here the k is called the spring constant, and we have a negative sign because, well, the restoring force acts in the opposite direction to the displacement produced. So here we can write force as mass into acceleration equals to m minus k by y, or acceleration equals to minus k by my. Well, here the spring constant is a constant, the mass is also constant, so we can write A is directly proportional to y, which proves that the mass spring system is in simple harmonic motion. And similarly, we can compare it with A equals to minus omega square y, giving us omega equals to root k by m. Therefore, the time period is equals to 2 pi by omega, which equals to 2 pi root m by k. So this is the time period, and you can also get the frequency, which is just 1 by t. So this is required for the horizontal part. So now for the vertical part. It is almost quite same, but for our syllabus we will require two different parts of it with 3 diagrams. So here, let's say we have a first condition in which there is no mass applied to the body, so unstretched. The second part, there is some mass attached to the body, so here this gets displaced to a distance of x, and here the restoring force of is F1. And here let's say the third case, it is stretched further, the same mass, and here it displaces to y, and then this whole thing is F2. Now here the fourth one, again using the Hooke's law, is directly proportional to x, the extension produced, right? So here F1 is equals to minus kx, and the same reason with the horizontal one. And Similarly, F2 is equals to minus K. Well, here F2 is the whole restoring force. So from here to here, so that means this is both the extension of X plus Y. The force 2 is due to the extension of both X and Y. So we put it as like that. So now here, if you have stretched it up to a point Y, then from X, let's say, after putting the mass, then if you release the body, then the body will oscillate up and down with the net force of F2 minus F1, because you have already have the body here without any force, and you put some force here. So this is F2 minus F1, that is the restoring force in which it oscillates upon. So here the net force is equals to F2 minus F1, which is equals to minus K X plus Y minus Kx. So F will be equals to minus Ky. And again, using mass into acceleration equals to minus Ky, you'll again get E equals to minus K by my. Therefore, A is directly proportional to Y, which is simple harmonic motion. And again, time period, let's write it directly, is 2 pi root m by k. So this is it for today, and I'll be covering the total energy in the total energy during simple harmonic motion, and also the angular simple harmonic motion in the next video. Thank you.